In this video I'm going to be working out an individual integral. It will be a trig integral, and I will be referencing this double angle formula. Cosine 2x is equal to 1 minus 2 sine squared x. Alright, it's a good thing anytime you're working with your trig functions to have a really good grasp on double angle formulas, your half angle formulas, or your Pythagorean identities, because you do a lot of substituting there. So in this first problem right here, I'm going to do the integral of cosine x 1 minus cosine 2x. That cosine 2x is what we are going to do that substitution with. So then I'm going to have the integral of a cosine x on top, and then I'll have a 1 minus, and then we got to remember, since this is a quantity, put that set of parentheses in, 1 minus 2 sine squared x there, dx. Alright, making that substitution right there, and then simplifying the denominator. 1 minus 1 is going to fall out, a minus a negative 2 sine squared x there is just going to give me a positive 2 sine squared x there. So we'll have cosine x in the top, and simplifying there in the bottom, I'll have a 2 sine squared x dx. Now at that point, some people might not be able to easily see what you're going to need to do a u substitution with here, but if you rewrite that so that you can see it's a sine x squared, that may help. So that's what I'm going to do in this next step. We'll have cosine x, and then we'll have 2 sine x quantity squared. Alright, doing that, you can clearly see the inside function right here is a sine x, so that's what we're going to let our u be. So we're going to let u equal sine x. That means du then is going to be cosine x dx, and going ahead and solving for dx there, we'd have a du over cosine x equaling our dx. Okay, so from there then we'll come up and we will do some substituting here. We'll have cosine x in our numerator, and we will have a u in the bottom there, so 2u squared. Replacing dx with what it equals, du over cosine x. That's going to allow those cosine x's to fall out, and then that's also going to allow me to then pull out a 1/2 outside of this integral. So let's do that right here. Let's pull the 1/2 out here. We'll have a 1 over a u squared du. And to integrate this, be easier just to move that up and make that a u to the negative 2. So I'll have a 1/2 integral of u to the negative 2 du. We are now to something that we can integrate. So I'll have a 1/2. Integrating that, let's see, adding 1 right there is going to give me a negative 1 u to the negative 1. We'll go ahead and throw in that plus c at this point. Alright, I think I'm going to come up here to finish it. Let's go ahead and move that to the bottom and multiply the negative times the 1/2. So at this point I'll have a negative 1/2 times 1 over u, and then plus c. If we replace u with what we know it to be, then we have a negative 1/2 times a 1 over sine x. And going ahead and substituting that out, because we know what 1 over sine is. 1 over sine is cosecant. So we'll have a final answer of negative 1/2 cosecant x plus c. So in all honesty, this is probably about a Calc 1 level integral. Not that difficult once you get that original substitution there. Once you see that you're going to have to substitute a double angle formula for there, it's pretty much a straightforward u substitution integral. Definitely thanks for watching. If the videos are helping, please share with your friends so that they can benefit as well, and don't forget to subscribe to the channel. Thanks.